Great Greek scientist Archimedes' Eureka moment is quite popular. Why did Archimedes get so excited about his thought experiment? What was the concept he deduced while he was taking a bath? More importantly, did Archimedes solve his king's crown problem using an immersing experiment or a float balance? The king of Syracuse was suspicious about his crown's gold quality. There were rumors that the goldsmith had mixed silver with the gold and cheated him. The king gave the task of checking the quality of gold to his most intelligent scientist, 22-year-old Archimedes. Archimedes found a solution to this problem by discovering one of the most important principles of physics, what came to be known as the Archimedes principle. First, let's understand Archimedes' principle conceptually, and then we'll come back and see how Archimedes solved this interesting problem. Consider this situation. Assume this wood block is less dense than water. Now, let's try to immerse that wood block in water. As you can imagine, the wood block won't stay submerged. When you release your hand, it will float as shown. Why can't the wood block stay under the water, where you left it? Let's freeze here and analyze the block at the exact moment the woman releases it. The block can't stay in place because the surrounding fluid exerts a force on the wood block, which is more than its weight. This force is known as buoyancy force. Archimedes' principle states that the value of buoyancy force is the same as the weight of the fluid displaced by the object. Here, the water volume displaced by the block is shown. Obviously, the water volume's weight is more than the wood block's weight. This means the buoyancy force is more than the weight of the wood block, which is why the block moves upward as you release your hand. Now, let's analyze the block in its equilibrium position. At the equilibrium position, the block displaces a much smaller volume of water. Here, if you check the weight of the displaced water, it will be the same as the weight of the block. In short, at the equilibrium position, the buoyancy force and the weight of the block balances. Force due to the Archimedes principle is not a new law in physics. In fact, one can easily derive it using the laws of classical physics. Let's see how. The pressure is different at the top and bottom of an object due to the height difference, and this pressure difference causes buoyancy force. Let's derive the values of these pressures mathematically. You can see that the resultant force is the same as that of the weight of the displaced fluid volume. An interesting thought experiment can also prove the Archimedes principle. Assume the space occupied by the wooden block is replaced by water volume of the same size. This is a very simple situation. The water volume inside the lines should be in equilibrium, which means the surrounding water should exert a force equal to the weight of the water inside. There you have it. The force exerted by the surrounding fluid is the same as the weight of the displaced water. This exactly is the Archimedes principle. Now, let's see how Archimedes solved the crown problem using his new principle. If the goldsmith had mixed silver, which is a lighter metal than gold, into the crown, its volume would be more than a pure gold lump of the same mass. Many people believe that Archimedes checked the purity difference by finding out this volume difference. They maintain that all he would have to do was immerse both the crown and a lump of pure gold in buckets full of water. If the bucket with the crown displaced more water, the crown would be impure. However, assume that the goldsmith had mixed in 10% silver. The volume difference in water displaced would be too negligible to notice. Therefore, this is not a practical method. Moreover, this is a simple volume measurement method. There is no application of Archimedes' principle here. Archimedes checked the purity of the gold by using a simple and brilliant experiment, a simple weight balance method. Both the crown and gold lump have the same weight. Assume the crown was impure. This means the crown will have a higher volume. He immersed the weight balance in water. The buoyancy force on the crown was more than the gold lump due to its higher volume. This means the net force on the gold lump would be more than the net force on the crown. A balance would tilt due to this force difference. Archimedes discovered the goldsmith's cheating by measuring the difference in buoyancy force. This is why Archimedes got so excited during his bath. He realized that any object surrounding a fluid receives a force from the fluid, with a magnitude equal to the displaced fluid's weight, and this force will be in opposite direction to the object's weight. We hope this video gave you a clear understanding about the Archimedes principle and buoyancy force.